All right, good morning, grade nines. Welcome back to our video lessons for mathematics. We are going to move on today to unit number 4, which is polynomials. Before we get into that, I do have a few things that I just want to talk to you about in terms of what our next few lessons are going to look like. So a good majority of you did that student progress check-in that I had asked you to do, which is awesome. Out of I have just over 50 of you in grade 9 math, and 36 of you did it. So that's a good turnout. If you are one of those 15 that haven't done it yet, I would ask that you please do that as soon as you can, because it gives me a nice it's almost like an attendance check in a way. I can just check that you are in fact following along with what we're supposed to be doing at home. So please do that. For the rest of you that have, that's awesome. I got some really good information. So there was some mixed feedback on the interest level of doing a live Google Meet for a lesson. So what I'm going to end up doing is I'm not going to make it mandatory, but on Thursdays, I'm going to have an hour or two in the middle of the day where I'll have a live Google Meet going. I will drop the link in the Google Classroom. I'm going to be spending that time just marking and doing some assessment stuff. And if you want to drop in and ask a question or two about math because something's not making sense, by all means, that is your opportunity to be able to get a real-time answer from myself. Those of you that have been asking questions over email, that's awesome. Sometimes it's just even easier if you can see me actually do the problem in front of you. So if that interests you, that'll be happening on Thursdays for about a 2-hour window. Now, if that doesn't interest you, that's fine. Like I said, not mandatory, okay? What else do I want to talk about? I've got some decent return rates here on you handing in the OLA. So we are on OLA number 3, and I have had 29 of you hand them in. So that's about half. So the other half of you, I need you to try to hand those OLAs in ASAP. You know who you are. And I will get you your OLA 2 marks back to you tomorrow. So tomorrow I'll be doing a whole bunch of marking and releasing a whole bunch of your marks. So for what that means for you for tomorrow is it's going to be kind of like a work period. Anyways, let's move on to polynomials. If you haven't been watching the other videos, you can watch them all for the powers and exponents. And since we're done that unit, we're going to have to do some sort of end of unit assessment. We'll be discussing what that looks like next week, because I'm still kind of just getting more information about what my assessment will be looking like when we're doing this all from home. So let's get started on the notes. I gotta full screen this and share it. There we go. Are we good? We are good. All right, so it seems like that might be a little bit bright. I've got my window open in here. The glare is a little bit too much. Is that better? That looks better. Okay, so let's just move this down like that and hide that. Polynomials. So this is our next unit that we're going to be doing together. Polynomials will be, I'm still trying to get this lighting right. I want a little bit more natural light in here. I have. How does that look? I think that's good. All right, polynomials. Let's get started. So, unit 4.1. In your so we're keeping up with that kind of confusing bit that in your textbook, unit 4.1 is chapter 5 in your textbook. So you'll notice that on the Google Classroom, I posted chapter 5's notes. So if you're doing the electronic copy, it'll be there on the Google Classroom. If you have your own copy, it's chapter 5. I think it is page 210. Yeah, 210. So let's get some fun colors out here. And let's start with, all right, what is a polynomial? What is a polynomial? The definition of a polynomial is it is either one term or the sum of terms whose variables have whole number exponents. So the key here is that we are not raising anything to the 1/2 or to, we're not having any sort of numerator denominator scenario. We have one term or the sum of terms who are all in the numerator, and they all have whole number exponents. So here's a very simple example. 3x squared, or maybe not simple, but a very standard example. 3x squared minus 2x plus 5. So this is a very, very standard example. Note, it is not a polynomial when the variable is either in the denominator or under a square root. And a square root is just being raised to 1/2. That kind of makes sense anyways. So here are some examples of non-polynomials right here. Okay. So if we have a square root inside of the polynomial, or sorry, inside of our terms, or if we have a fraction inside of our terms, that means that we have a non-polynomial going on. Now, some other key words that we need to remember when we're discussing polynomials. The first one is terms. What does it mean to be a term? A term is either a number, a variable, or the product of a number and variable. Okay, so it's basically just that all-encompassing term for each of the individual spots inside of our polynomial. Is this? I need to focus this. Oh yeah, it's way better, right? I think. What is a constant term? A constant term is the same thing as a term, but it is a value that does not change. It does not change. So it's a number that doesn't have a variable. What's a variable, you might be thinking? A variable is actually a letter. It's any letter that represents a number. But the thing is that that number that it represents can change. Okay? The most commonly used letter that we're going to see is X, but that doesn't mean that we don't see other letters as well. Even down here below, you can see I've got some K's here. Okay, so a variable is any letter that represents a number. A coefficient is the number in front of the variable. The number in front of the variable. And then finally, the degree is the greatest exponent. Remember, we already learned about what exponents are. Okay, exponent is the number that the value is going to be raised to. Remember, you've got your base and you've got your powers, the two of them are your base, and then your exponent is the one that's up above. So the greatest exponent gives you what the degree of the polynomial is. Take a look at this example below. The term with the greatest exponent determines the degree of the polynomial. So this entire polynomial here has a degree of 2 because it is the greatest exponent. This term itself individually has a degree 1, so that means that it's not as big as the degree 2, so the degree of the polynomial is 2. Okay, and then the term 5 here, this is our constant term. This is a value that does not change. Okay, so even if x changes to be 2 or 5 or 3 million, it doesn't matter. This 5 doesn't change. So this is our constant term. Constant term technically has a degree of 0, because if this was 5 times x to the 0, well, hey, you tell me, we've done this before. What is x to the 0? Just 1, right? It's just 1. So this is technically just 5 times 1. So what you'll see here is we technically have 3 to the x squared, and then minus 2 to the x to the 1, and then plus 5 to the x to the 0. Okay, but the x to the 1, well, the 1 we don't have to write. The x is right there. And x to the 0, that's just 1. So we don't have to write it either. So what you'll notice is our degrees actually are decreasing as we move from left to right. And that is my next thing that I wanted to mention to you, is that polynomials are usually written in terms, or we want to convert them so that they're written in terms of descending order of exponents. We start with the largest exponent and we end with the smallest one. For example, this polynomial here, this is a fine polynomial, but it's not written how we want it to be written. So it's 2k minus 4k squared plus 7. What we would like that to say is minus 4k squared plus 2k plus 7. It gives us a good idea of what our degree is because it's the first one, right? And it shows them all in descending order. It's just a nice way to organize all of our terms. Let's move on. So you might see a question like this where you have to determine the terms, the constant term, the variables, the coefficients of the following polynomial. So let's start with the terms. Now, some of you might be thinking already again, okay, wait, what's a term? I don't remember. Well, let's take a look back here. A term is the numbers, variables, and product of number and variables. It's basically just everything. For our terms, we've got 3x squared, we've got negative 5x, and we've got 6. Those are all terms. What's the constant term? This one's pretty straightforward. The constant term is the one that doesn't have the variable inside of it. That's 6. That's the one that doesn't have the x attached to it. It can't ever change. It's always going to be 6. What are the variables? Now, technically, our only variable here is is x. So our variable is x. That's what we're using. I'm actually going to just say that we've got a variable of x squared and a variable of x. That way we just know that we've got, x to the power of 2 and x to the power of 1. So there's our variables. And then finally, what are our coefficients? What are our coefficients? Our coefficients are, I guess I should make this I like that too. All right, our coefficients are 3 and negative 5. So we've got the 3 in front of the x squared, and we've got the negative 5 in front of the x. Okay, so there you go. There are all of our different different math lingo that we're learning for today. Now, how do we classify polynomials? We classify polynomials based on the number of terms that they have. A polynomial with one term has a different name than a polynomial with 2 terms, which has a different name than a polynomial with 3 terms. Okay, and we use something called a prefix change to specify between these. Remember these prefixes, they will come up again in your grade 10 science. So if you want to impress your teacher, you can remember these. 1 means mono. Mono means 1. So a monomial has a 1 term only. For example, 4a or 6 or negative 2p squared, okay? But it's just 1 term. A binomial has 2 terms. So something that looks like 2c minus 5 or 2m squared plus 3m, okay? Or it could be 3y squared plus 17. I don't know, okay? Could be, as long as it's just got 2 terms, it doesn't matter. A trinomial has 3 terms. So our example here is 2h squared minus 6h plus 4. Okay, I could give you another example here. This could be 3 q squared plus 9. Look, my q's look a lot like my 9, so that was a good number to choose. 9q minus 23. That could be one as well. Okay. All right. So how do we model polynomials? We use something called algebra tiles to model polynomials. I don't know if you guys remember using algebra tiles before. I do believe that you have used them in the past. I'm going to use the colors red and yellow because that's what it uses in your textbook. And we've got 3 different types of algebra tiles that we need to know how to write out. In arithmetic back in the day, you would have used base 10 blocks to model whole numbers. You've got something that looks like this. And then you've got the ones that look like this. And then you've got just the individual little ones. Okay, and in base 10 blocks, this represents 100, this represents 10, and this represents 1. Now, in algebra, these are called algebra tiles, and we use them to model the integers and the variables. Okay, I'm going to say that yellow represents positive values. And then whenever I use a red algebra tile, well, you guys already know that's red. I don't need to write red. I want to write negative. Red means that these are in negative values, and you can have the same three. It can look like this, it can look like this, and it can look like this. Now, what do these mean? What do these represent? Whereas in base 10, this was 110 and 1. Now, what these are x squared. If that's x squared, that means that this is just x, right? This is x multiplied by x will give us x squared. And then one of the x's, say x is, it doesn't matter what x is. X could be 3, x could be 10, x could be 2,000, but just one of them is just going to be 1. So there's our different values. This right here is x squared, this is x, and this is 1. So that's how we use algebra tiles. Now the difference here is the red represents the negative. So this is negative x squared, negative x, and negative 1. So there are our algebra tiles, and you're going to have some practice problems to do in the textbook. I've got a couple that I want to do together with you first. Oops, got my paper. So this question, recognizing the same polynomials in different variables. And these are also written in different orders too, which makes it more difficult. So we've got three different problems here. A is 3x squared minus 5x plus 6. B is negative 5 plus 6r plus 3r squared. And C, I'll do B over here, and we'll do C down here. And C is negative 5m plus 6 plus 3m squared. So what I'm going to do, it's a nice visualization. I'm going to draw these out in their algebra tiles. So I have, in part A, I have 3x squareds, right? I have 3 of them. That's what the coefficient means. It means I have 3x squareds. And for my last one, remember, x squared, if it's positive, was the big square. So there's 1x squared. There's another x squared. And there's another x squared. Okay, and then minus 5x, that means that I have negative 5 of the x's. So 1, 2, 3, 4, 5. And remember, I'm using the red color because it's negative. And then 6 of the positive ones, right? Because plus 6 would be plus 1 plus 1 plus 1 plus 1 plus 1 6 times. So there we go. 1, 2, 3, 4, 5, and 6. So now we have a nice visual representation of what this A is telling us. Let's do it for parts B and C, and let's see which ones are the same. So this one, I'm starting with negative 5. 1, 2, 3, 4, 5. And then I have plus 6r. So already this is not looking the same as the other one. 1, 2, 3, 4, 5, 6. And plus 3r squared. So that part is the same. We have 3 of these big squares. There's 1, there's 2, and there's 3. So already we can see, okay, so these are the same, but the x's and the ones are different. Let's do part C here and see what we get. We have negative 5m. That's going to be negative 5m is going to be 5 of these red ones. 2, 3, 4, 5. And then plus 6, that's going to be 6 of these. 1, 2, 3, 4, 5, 6. So far, so good. We just need to check. Yes, it looks really good. We've got plus 3m, which is going to be 3 of these big boys here. 1, 2, and 3 of the big squares. And we can see that, I'm just going to separate these. That we've got the exact same thing going on here in A and C. So we can write that here. A and C are the same. And it says justify it. Well, we justified it by showing our algebra tiles. So we're good. Example number 2. This is our last example. Then you can work on the practice problems today and tomorrow. Use algebra tiles to model each of the following polynomials. So this shouldn't be too difficult. We've got 3 of them. We'll start with A. A is going to be particularly quick. It's just negative 2x squared. So first thing I think of, negative 2, I know I'm using red. Okay. Next thing, x squared means I'm using the big squares, representing x squared. And there's 2 of them. So 1 and 2. Easy as that. Let's do B. B, I've got 2b squared. Immediately, I see it's a positive, so I get my yellow ready here. You don't have to use the same colors, just as long as you have 2 different colors to represent positives and negatives, and you're being consistent. The 2b squared, that means I have 2 of the positive ones. There's 1, and there's 2. And then minus b, well, that's just technically 1. So minus 1b. And then plus 4. So I have 1, 2, 3, 4. And there we go, finished. And then C is 5a. That's a positive. There's no squared, so it's just going to be 5a is just going to be 5 of these. 3, 4, 5. And then minus 3. So we just have 3 of these. 1, 2, 3. Let's do a little extension question here. And I want you to think, you can pause the video right after I ask this. What are each of these? Which of these is a trinomial? Which of these is a binomial? Which of these is a monomial? Okay. This only has 1 term, right? So this one would be our monomial. It's a hard word to say, monomial. This one has 3 terms. This one would be our trinomial. And this one has 2 terms. This one would be our binomial. Okay. So we are making great progress here. That's going to be where we're going to end it for today. So with our little extension question there. If you are watching the video and you've made it this far, congratulations, you made it to the end. For the textbook questions, which I can see here, hold on, are on page, they're on the next page, 213. So it's page 213. I want you to do questions 1, 2, 4, A to C, 7, 8, and 12. That's it. Okay, and that's it for the lesson. Again, if you're looking for some extra help, some stuff's not making sense in maybe the previous unit or even just in this lesson today, you can drop by. I will post, it'll be around noon or so. I think I'll probably start it at 11 and go till 1. You can drop by and ask some questions on a Google Meet, and I will be able to answer you in real time. Could be useful. Like I said, not mandatory, because I know that there wasn't full interest in doing that. Some people weren't interested in that, and that's fine. So thanks for following along. We'll talk to you again soon.